Let's take a few minutes to review the reactions that we already know for carboxylic acids and to talk about the reactions that we're going to discuss in this chapter. We already know from the chapter on alcohols that we can interconvert a primary alcohol and a carboxylic acid through oxidation reduction reactions, where we use the stronger oxidizing agent and reducing agent respectively. We know that we can make an ester from a carboxylic acid. We're also combining that with an alcohol. And the mechanism for this reaction is actually presented in this chapter too, but we're not going to do that until the next chapter. We are also reminded in this chapter that we can create a carboxylic acid chloride or bromide in a more general sense called an acid halide, using either SOCl2 for the chlorine or PBr3 for the bromine. This is analogous to similar reactions with alcohols. And I say we're reminded that we may or may not have learned that before, but we have it in this chapter. And in terms of new chemistry, we also know from the alcohol chapter that we can convert those functional groups into esters as well using an alcohol, but we'll go over that in chapter 20. Now, in terms of new reactions that form carboxylic acids, we have a couple, namely the use of an organometallic like a Grignard reagent, with carbon dioxide followed by H3O+. We can also hydrolyze a nitrile. This can be done with either acid or base. And we'll go over that reaction in more detail in chapter 20 as well. And it's important to remember that we can use a alkyl halide with a cyanide ion like sodium or potassium cyanide to create that nitrile, and that actually adds an additional carbon to our carboxylic acid. And we do this with the organometallics as well. So if we consider a Grignard reagent, we're making carboxylic acid while adding a new carbon by using both of those methods. We also have a new reaction of carboxylic acids in this chapter called decarboxylation. Which is the loss of CO2 or carbon dioxide. So we use that little minus sign to indicate that. And this only works on very specific cases, which we'll talk about in the decarboxylation video, but is worth mentioning in our reaction overview. The last one, by the way, we should remember from way back when is that carboxylic acids are weakly acidic, and therefore it's easy to deprotonate them.